Hey everyone, and welcome. Today we're diving into some really cool agricultural science. We're going to look at how a specific kind of biostimulant can, well, basically teach crops how to defend themselves against some of their biggest threats. Let's get into it.
You know, for any plant out in the field, life is a constant fight. From one side, you've got environmental stress, like a serious drought, and from the other, you have biological threats. We're talking insects, pathogens, you name it. All that pressure leads to weaker growth, lower yields, and even cell damage. So the big question is, how do we give our crops a real fighting chance?
Well, it turns out the answer might not just be about feeding the plant, but about training it. This is where a water-soluble fertilizer with humic acid comes in. I want you to think of it less like a meal and more like a personal trainer for the plant, building up its natural fitness and resilience from the inside out.
Okay, so what is this stuff, really? What you're looking at is a liquid fertilizer that's completely water-soluble. It's made to deliver not just those essential macronutrients, your N, P, and K, but also that really critical ingredient, humic acid, all the way through the crop's entire life cycle. Now that key term here is biostimulant. It's super important to get this. It's not just another nutrient. A biostimulant is a substance that actually triggers a plant's own natural processes. It helps the plant use nutrients more efficiently, it boosts its tolerance to stress, and at the end of the day, it improves the quality of the crop. It's all about empowering the plant, not just force-feeding it.
All right, for all you agricultural technicians watching, let's quickly hit the specs. The formulation has a total NPK content of 200 grams per liter, and the humic acid content is sitting at 30 grams per liter. And because it's completely water-soluble, it's perfect for direct application.
So, how does this personal trainer actually get the job done? Let's break down the first big mechanism, helping plants conquer drought. And in today's unpredictable climates, this is absolutely crucial. And here's the key thing. This stuff fundamentally changes how the plant manages its water. It's not about trying to add more water to the soil. It's about making the plant drastically more efficient with every single drop it can find. Now, this is really interesting when you break it down. First off, it directly improves the plant's water use efficiency, so it's doing more with less. Second, when things get tough, it helps the plant hold on longer, delaying those visible signs of wilting. And third, and this might be the most important one, it promotes a bigger, stronger root system, so the plant can physically reach more water deeper in the soil. And wow, this picture says it all, doesn't it? This perfectly illustrates that last point. I mean, you don't need to be a scientist to see the difference. On the left is the control, but on the right, the celery treated with the potassium humate fertilizer. Just look at the sheer density and mass of that root system. That is a plant that is built to find water. Okay, so that's how it handles environmental stress. But that's not all it does. Let's move on to the second major benefit. This biostimulant also helps the plant fight back against pests and diseases by basically activating its own internal defenses. This is such a different way of thinking about it, right? Instead of just spraying an external chemical to deal with a problem, the whole idea here is to trigger the plant's own natural immune system, to wake it up and get it ready for a fight.
So how does it do that? Well, on a biological level, it literally activates the plant's specific defense genes. That kicks off the production of defensive proteins and something called anti-feedants, which make the plant taste bad to pests. On top of that, it has antimicrobial properties and can even help reduce damage from other stresses, like floods. It's a full-on defense package.
Now, the science is pretty compelling, I think you'll agree. But for anyone working in agriculture, the real question is always, what does this actually look like out in the field? Let's look at the results, because seeing is believing. Here's a really simple, direct comparison. On the right, you've got a seedling before application, and on the left, after. The difference isn't just that it's a little bigger, it's a visibly stronger seedling with a much more complex root system that's ready to thrive after transplanting. And if you thought that was impressive, check this out when you scale it up to an entire field. That line right down the middle tells the whole story. On the right, the control group, that's your before. On the left, the section treated with the fertilizer, the after. The difference in the size, the color, the overall health is just dramatic. That's a huge increase in yield potential you can see with your own eyes. So let's just boil this all down. What are the key takeaways? First, you're getting much better drought resistance, thanks to smarter water use and way stronger roots. Second, you get a boost in disease resistance because you're turning on the plant's own defenses. And the result, the bottom line, it's exactly what every agricultural professional is looking for. Healthier, more resilient crops with a much higher potential for yield.
And this really brings us to a final, pretty big question. As we face more and more extreme weather and environmental challenges, just adding more inputs might not be the answer anymore. So could the future of sustainable agriculture actually lie in working smarter, not harder? By empowering the incredible built-in resilience of the plant itself? Definitely something to think about.